Gypsum recycling using an inclined chamber vibrating jaw crusher. There are almost 160,000 buildings and structures in Ukraine that were destroyed due to Russian aggression and need to be restored and repaired. Hundreds of thousands of tons of construction waste generated as a result of the destruction of buildings contain valuable secondary resources: metal, concrete, glass and bricks, etc. Broken concrete, bricks, tiles, glass, elements of wood, plastic, gypsum, scrap metals, ferrous and non-ferrous, bituminous mixtures and resins, stones, insulating materials, chemical substances, packaging materials. This includes gypsum waste, most of which is gypsum drywall. Gypsum waste, harmless in its isolated state, when disposed of in a landfill, causes environmental problems by polluting groundwater, emitting hydrogen sulfide and greenhouse gases. Landfill disposal is the easiest and lowest level of waste disposal, causing significant environmental damage. Gypsum is one of the materials widely used in construction along with cement. This natural material is also used in many industries and agriculture. In Ukraine, the Donetsk Basin has the largest reserves and production of gypsum and anhydrite. A significant portion of the explored deposits are located in the Bakhmut district. A large number of enterprises are located in the Luhansk region and Crimea. Since all these enterprises are in temporarily occupied territory or the war zone, the main production of gypsum has shifted to Prikapatia. The decrease in production can be partially offset by recycling industrial and construction waste gypsum materials. One such material is gypsum board, which uses over 80% of the extracted gypsum in its production. Gypsum drywall, a key component in most modern buildings, is made by sandwiching a dense gypsum core between two layers of specially treated paper, cardboard. The composition of a typical drywall board is roughly 93% gypsum, 6% paper facings, 1% moisture, starches, and organic surfactants. Millions, or even tens of millions of tons of gypsum waste are generated globally each year. The primary sources of this waste include production waste, rejects and substandard gypsum products, construction waste, scraps generated during drywall assembly, demolition and renovation waste, drywall removed from buildings, which may have higher contamination levels. The main processing tasks are the separation of the cardboard shell and the shredding of the gypsum core. Currently existing technologies of gypsum board processing do not have any noticeable differences. Technological schemes provide for the conversion of the entire mass of gypsum board into a fine-grained product and further separation in a drum separator into gypsum component and paper. The disc shredder of Turkish company Mykola is widely used, and the separator is made in the form of a cylindrical chamber with an internal rod, shaft and perforated bottom part of the chamber. The general disadvantage of the currently used crushing and shredding equipment is the processing of gypsum board into a mixed fine-grained product, which significantly complicates the qualitative separation of components. The physical picture of gypsum drywall fracture by a single impact with different shape of the impactor surface was determined on the developed laboratory impact tester. The tester includes a pendulum, a suspension axis, a bearing assembly of a replaceable weight and an impactor. The centers of mass of the weight and the impactor are located on a common vertical axis distant from the pendulum suspension axis at a distance of 1 meter. Mounting of the impactor allows to set a different profile of the working surface interacting with the material under study. The height of the impactor lifting, dropping, is determined by the measuring system containing a curvilinear bar rigidly connected with the pendulum, suspension axis and a tracking mechanism. The mechanism is made in the form of a cylinder with a piston and a pressure spring inside. This system also makes it possible to track the character of interaction of the impactor with the material under study. For the same purpose, an acceleration sensor is attached to the impactor assembly to record changes in acceleration in the vertical plane. The smooth surface of the impactor produced no visible damage to the gypsum board sample. The pyramidal surface completely separates the upper shell of the gypsum board while keeping the gypsum core intact. The prismatic profile tears the upper shell and compacts the gypsum core. The best result is obtained with the oval profile of the striker surface. In essence, the top shell is removed without much damage and the gypsum core is extensively fractured. This profile of the liner surface was adopted for installation on the vibrating jaw crusher for further research. Crushing was performed on a laboratory sample of vibrating jaw crusher. The crusher includes a passive, lower, crushing jaw 1, mounted on elastic elements 5 and simultaneously acting as a body. The active jaw 3 is mounted and the passive jaw stands by means of a suspension axis 2, against which it can make rotary oscillations. Jaw vibrations are generated by a twin-shaft inertial vibration exciter 4. The material is crushed in the crushing chamber formed by the working surfaces of the passive 1 and active 2 jaws. Strips of 5 mm thick and 130 mm wide NAF blue drywall, identical to those studied on the impact tester, were subjected to crushing. Based on the studies on the impact tester, the lining surface of the active jaw is made by a set of oval rods. On the inner side of the unbroken cardboard plates there is an insignificant residual gypsum deposit, and the gypsum core has a sufficiently high degree of crushing. Thus, the original composite material is divided into 3 constituent parts, which are already secondary raw materials. The resulting shape of the crushed product allows for a fairly simple separation on the screening surface. The fraction 0 to 200 microns after calcination restores the properties of gypsum and can be used in the production of gypsum drywall, construction material, etc. Larger fractions, as finished commodity products, find application in agriculture, cement production, landscape design, etc. This indicates the feasibility of processing gypsum drywall waste at the place of its formation, to obtain marketable products, reduce transportation costs, relieve landfills, improve the environment and save mineral resources. Thank you for attention.